All right, so this is a third problem. It's number 6 from the general round. And we have this functional equation. So we have a function f from the set of integers to the set of integers that satisfies this condition. And this a number n is called good if for any integer n that we pick, we can find a function f that satisfies this equation for which f of n equals n.
It is worth noticing that there are actually infinite number of function f that satisfy this.
So, in particular, if n is good, it means that we should be able to make f of n whatever we want it to be.
Yes.
That's basically what it's saying.
Yes, and the goal is to find getting all good numbers. So when I see this problem, it seems to be non-standard, but it seems to have really two constructing elements. So first of all, if n is good, which means that f of n can be anything we want, so it has a lot of freedom. However, we look at this as f of something equals 15. And 15 is a fixed value, which means that this thing cannot have a lot of freedom. So what I'm thinking is that we will make the somehow collide. So our goal is to make this dot dot dot, or actually f of n plus 2n plus 20 equals n. So we know that we can do this because f n can be anything. So we can force this to be f equals negative n minus 20.
Wait, just a second. If you force f of n plus 2n plus 20 to be n, then f of n must be 15, right?
Yes.
Let's write it down to the right of it or something.
Yeah, so this gives us that f of n equals 15.
And if you prove that some other number is 15, you get a contradiction because a function cannot map two values.
Yes, that's basically the key. So because f n has a lot of freedom, we can set it to be negative n minus 20. Which means that when we plug n into here, we get that f of n equals 15. So that here, it means that both of these must hold true. So these two give us negative n minus 20 equals 15, or n equals negative 35. So I'm pretty sure a lot of people in the contest when they get negative 35. And we see how like this is the only possible answer. They'll probably stop here and say negative 35, and this is the right answer. But here we want to show that it actually works, that negative 35 is actually good. So once again, we want to basically want to find for any n there exists a function such as f of negative 35 plus n. So let's look at this. So f of negative 35 equals n. And we see that a lot of stuff equals that, and we see that f of something equals 15. So why don't we just make everything else equals 15? And x is not equal to negative 35. So this is our definition of function. And let's see how it turns out. So if we plug in x not equal to 15, not equal to negative 35 inside, then we get this f of 15 plus 2x plus 20 equals 15. And since x is not equal to 35, we can show that 2x plus 35 is also not equal to negative 35. So which means that this thing, and this definition is also 15. So now we plug in x equals negative 35. So now we have f of m minus 17 plus 20 equals 15. So let's see. So if first of all, if n is equal to 15, then this is f of m negative 35, which is 15 is m, which is 15. Yes. So if m is not equal to 15, then we see that m minus 17 plus 20 is not equal to 35, which means that we're also, because this thing is not negative 35, which means that this thing still has to be 15. So now we show that for any n, there we construct a function that satisfies this property. So now we show that negative 35 is actually good. So we're done.
Okay, I think this part was already explained.
Yeah, we can go over that part again because I think Vinci, you and I are still looking at it.
Yeah. Because okay, why are you saying that f of n plus 2n plus 20 equals n? Like I think a lot of people will be confused by that statement. Why does it have to equal n?
So my point of view is that f of n can be anything. So in order for anything interesting to happen, we want this to be equal to n. So we're kind of abusing this freedom right now. Because this thing can be anything, we can set this to negative n minus 1.
Okay, but how do you know that setting it to something else won't give you something bad? Or won't give you like an alternate good value? Like what if some other function f could give you something other than negative 35 as an answer?
So here my logic is when n is good, then there exists a function such as this is true. After I got the Q value, why would I want to set this to this? If n is good, there must exist a function such as this is true.
Okay.
Yes.
So that's because negative n minus 20 is a constant.
See here, I would actually.
Okay, so basically,
yes.
so your logic is if n is good, there must exist a function f such that f of n at that particular value is equal to negative n minus 20.
Yes.
And that's because of the good condition. Because you're setting n to be negative n minus 20.
Yes.
Okay. And then from there we get f of n equals 15, which means that n is negative 35.
Yes.
So n is good
Because n
has
has
to be negative 35.
And this is the only possible candidate.
This, yeah.
Now you want to be finish it, you want to construct such function.
Yes.
And that was
And
your
then
construction.
here's the construction. Yes. So this part is kind of like tricky as in logic because we have to realize that as long as we say n is good, n is already fixed. So which means that we can do whatever thing we want with f of n to get any contradiction we want.